Yeah, happy to see you all again. And here we are going to see about chapter number 11, work and energy. And in this chapter, we are dealing with work and energy. Initially, we are going to see about work. Generally, what is work? Yes? Okay. Here I have chalk piece, right? So, I am holding this chalk piece in my palm, right? Am I doing any work on that chalk? Am I doing any work on that chalk? No, right? I'm just holding, right? Suppose the chalk piece is here, right? And lift this chalk piece to some height. Now, yes, of course, I am applying a force, and due to that applying force, I move some distance of this chalk piece. So here the work is done. It's clear? So generally, what is work means the work is done when by a force. If you are applying a force, what is force? Push or pull, right? We are studying in the lower classes. The force is defined as push or pull an object. So work is done by a force on an object. So we are applying a force on an object. If a force acts on the object, definitely the force should act on that object, right? And that is the first condition. And the second condition is the object is displaced. The object is displaced. This is the second condition. The object is displaced from its original position. If the two conditions is obeyed, then we can say that work is done. That we are saying that work is clear. So the definition of work is done by a force and an object. If a force acts on the object and the object is displaced from its original position. That's why I said initially the chalk piece is here. I am applying a force and lifted through some height. So original position is in this position, right? That finger. And the final position is located here. So the object gets displaced due to applying force. I am applying some force to lift this chalk piece, right? So here the very good example for work. Example, lift your book through a height. The second example, a bullock is pulling a cart. A bullock is pulling a cart. So these are all very good examples for work is done. And what you are going to do in the sense, here I have written 7 different categories, right? 7 different categories. You have to identify either work is done or not, right? This is your first homework in this video. This is your first homework in that video. You have to write all those 7 examples. This example is obeying work is done or not. That is your duty. You need to find out. So the first case, Suma is swimming in a pond. What will happen? Yes, he is applying force and he will move horizontally, right? So the work is done here. Similarly, you should identify all those 7. Right? Here I will tell you a donkey is carrying a load on its back. So carrying on a load on its back means there is no work done because there is no displacement, right? So therefore we are saying that this one is not work is done. This example is very good example for work is not done. And similarly, yes, a green plant is carrying out a photosynthesis. During photosynthesis there is no displacement, right? Yes, so there is no work is done here. And yes, food grains are getting dried in the sun. Food grains are getting dried in the sun. That is also work is not done. And similarly, the rest of the cases are work is done because we are applying a force. The object is moved from one original position to final position. I hope you understand well about what is work, right? And here we are going to see about work done by a constant force. I am applying a constant force. Due to that constant force, what is the work done? And we are going to derive the equation for work done. So let's take one small box. Okay. So example, instead of that box, I have chosen this metal scale. I am applying the force, right? What will happen? This metal scale displays along the direction of applied field, right? Along the direction of applied field. What about the direction of field? Towards my left hand side. Yes, the force is acting in that direction, right? So I am applying the force. The metal scale is also moving in the direction of applied force, right? And if F is a constant force acting in the direction of displacement S, yes, then work done by the force, we can write W is equal to F into S, or otherwise generally we can write Fs. Work done is equal to force into displacement. W is work done, F is force, S is displacement. Then what about the SI unit of work? Yes, absolutely, joule. Here the force and displacement are in the same direction. Therefore, we can conclude the work done is positive because the force and displacement are in the same direction. In that case, work done is positive. Suppose, assume that the scale is moving uniformly. I am applying opposite force to that displacement. What happened? This object is going to be stopped after applying this force. That time the force, the applied force, that is retarding force, here I note down, the retarding force which is opposite to the direction of displacement. So note down in this diagram the displacement in that direction towards my left hand side, and this retarding force is acting towards my right side. So in these cases the force, retarding force and this displacement both are acting in the opposite direction. We can conclude the work done is negative. When is positive? Work done is positive. When work done is positive, F and S are acting in the same direction. When the work done is negative, when the F and S are acting in the opposite direction, that time work done is negative, right? And here we are going to define 1 joule of work. What is 1 joule of work? The amount of work done when a force of, how much force we are applying? 1 Newton. When a force of 1 Newton moves a body through a distance of 1 meter. So 1 Newton force I am applying. Due to that 1 meter get displaced in that direction of force. Then we can say that this is 1 joule of work, right? I hope you understand well work done by constant force. W is equal to F into S, right? Thank you. See you in the next video. Here we are going to solve one problem using work done formula. The problem is a force of 7 Newton acts on an object. The displacement is say 8 meter. In the direction of the force as shown in the figure is given. Let us take if that the force acts on the object through the displacement. What is the work done in this case? So here they are given the diagram. We have an object. For that object we have applied 7 Newton. The object is displaced 8 meter. Then what is the work done? So given force is 7 Newton, displacement is 8 meter, work done they are asking. So 7 Newton of force they are applying and 8 meter they are get displaced in the direction of force. Work done they are asking. The formula for work done is F into S. F is 7 Newton and S displacement 8 meter. So 7 9s are 56. So force is S unit of Newton and the displacement is the S unit of meter. Either you can write W is equal to 56 Newton meter, or otherwise you can write W is equal to 56 Joule. Work, the S unit of work is Joule. Therefore we can write work done is equal to 56 Joule. And this question is your homework. And this is page number 149, question number 4, this question. And the typical formula you are going to use in that sub, right? I hope you understand well about this problem. Thank you. See you in the next video.